Hello everyone, I am Dr. Godindaraman. In this section we are going to discuss with central limit theorem introduction. The central limit theorem is one of the most remarkable result in probability theory and application. Many application probability theory the random variable of interest or the sum of other random variable. For example, electrical noise in communication system is due to the cumulative effect of large number of randomly moving charged particles. Broadly, the central limit theorem says that the probability distribution of the sum of large number of independent random variables approaches a normal distribution. So this is our application. Now, the form of central limit theorem, Liapounoff form, if x1, x2, etc. xen be a sequence of independent variables with the e of xi equal to mu I and variance of xi equal to sigma I square I equal to 1 to infinity, and if Sn equal to x1 plus x2 plus etc. plus xen, then under certain general condition Sn follows normal distribution with the mean mu equal to summation I from 1 to n mu I, and variance sigma square is nothing but summation I 1 to n sigma I square as n tends to infinity. So this is a form of Liapounoff form. Then central limit theorem, Lindeberg-Levy form, if x1, x2, etc. xen be a sequence of independent and identically distributed random variable with e of xi equal to mu and variance of xi equal to sigma square I equal to 1 2 3 infinity, and if Sn x1 plus x2 plus etc. plus xen, then under the certain general condition Sn follows a normal distribution with the mean n mu and variance n sigma square as n tends to infinity. So how to solve this Lindeberg? In this theorem we generally use we observe that expectation of Sn because of expectation of xi mu, variance of xi sigma square. Now this is a form. And then in central limit theorem, what is a corollary? If x bar is nothing but taking average x1 plus x2 plus etc. xn by n. Here x1 plus x2 plus etc. xn is nothing but Sn by n. Then expectation of x bar. How to calculate this? Expectation of x bar value Sn by n. That is nothing but x1 plus x2 plus up to xn. Now when I am taking this expectation of x bar, this is a by n, x bar, when I am taking expectation this expectation of x1 plus expectation of x2 plus up to plus expectation of xn by n. If expectation of x1 value mu, expectation of x2 value mu plus up to plus mu by n. So now this is a n times of mu. Therefore this term is nothing but n mu by n equal to mu. When I cancel this n mu, so this is a e of x bar equal to n mu by n equal to mu. Then variance. So variance is nothing but variance of xi. So expectation of this. So variance of xi is nothing but x1 x2 variance of x1 plus x2 plus x3 up to xn by n up to plus xn by n because of x bar, variance of x bar. Okay, variance of x bar, this calculation. Now variance of ax is nothing but a square of variance of x. Therefore this 1 by n square variance of x1 plus x2 plus up to xn. When I individual, I am taking this 1 by n square variance of x1 plus variance of x2 plus up to variance of xn. For this term, variance of x1 is nothing but n sigma square, because of the condition general variance of x, so sigma n sigma square. Therefore 1 by n square n sigma square plus here this variance of x1 is sigma square, variance of x sigma square. Therefore this variance of x1 is sigma 1 square, sigma 2 square up to sigma n square. So these are the sigma 1 square, sigma 2 square, sigma up to n square. It's a sigma square, sigma square n terms, variance of x1, x2, x3. This is a sigma square n terms. Now we consider this n square, sigma square plus up to plus sigma square. Now this is a n times. Therefore 1 by n square n into sigma square, n sigma square by n square, then the term is nothing but n cancel, n cancel. Therefore sigma square by n variance of x bar. So this is a we are expand this sigma square. So x bar follows a normal distribution with mean mu, variance sigma square by n as n tends to infinity. Then z equal to x bar minus mu by sigma by root n is a standard normal variate. So this is also the form of Sn is follows. Same procedure when expectation of x, when I am taking x1 plus x2 plus etc xen, then this term also expectation of x1. When I am taking expectation of x1 plus x2 plus etc xen, same process to consider this n into mu, because n number of times. And then n sigma square is nothing but variance of x1 sigma square, variance of x2 sigma square, variance of xn sigma square. We can make it thus the value of n into mu, n into sigma square. This is the same form, the value, because this is a variance of Sen n sigma square, the previous form, Lindeberg-Levy form. So this form only we can expand this mu, mean, variance, sigma square. So these are the form. So one is Liapounoff form, another is Lindeberg form, and this is our corollary. Thank you.